Okay, a lot of the work we do with the normal distribution is on, you'll be pleased to know, calculating probabilities. Underlying this work is the standard normal curve. So in the past, whatever normal distribution you had, you would have to map it onto the standard normal curve. And then you'd have a table of probabilities, and then you could work out the probability of being bigger than or less than a particular value in your distribution. The standard normal curve has a mean of 0 and a standard deviation of 1. So if you were finding the probability of being between -1 and 1, you would actually be finding the probability of being within 1 standard deviation of the mean on the standard normal curve. The total area under the standard normal curve is 1, and so this actually gives a probability distribution. So you can use the amount of area between your values to represent the probability, and that's the key thing to the normal distribution probabilities actually. We'll come back to this later on. For now you can ignore it, because the good news is that your calculator actually does all the hard work for you, which I kind of like but don't like, because you don't really need to understand it particularly well. So for this one here, I've got the normal distribution, mean of 30, standard deviation of 4, and we want to find the probability that x is less than 33. So if I draw this distribution, and we want the probability that x is less than 33, then I'm looking for this area once it's been mapped onto the standard normal curve. We don't need to worry about that bit. So we're trying to find this area, and the area under the graph is represented as being 1, the total area. So, calculator. This is a bit dark, I'm afraid, but I've got a link to another one that you can watch as well if you don't quite get it from this. If you go to menu and then option 7, or scroll around, and there's like a bell-shaped picture of a curve, press equals. So you used that last year for the binomial stuff, and we're looking at cumulative distributions. We're not going to use PD, so option 2. And for this one, my lower bound, x is less than 33. So these curves, because they're models, they're actually infinite. So x goes all the way up to positive infinity, all the way down to negative infinity. But obviously the probabilities tail off each way. So although there is a probability of x being, I don't know, less than 0 even, that probability is going to be really, really, really small. As a rule of thumb, you need to go 5 standard deviations away from the mean. So 5 times 4 is 20, 30 minus 20 is 10. And so I can put a lower bound of 10 in there, and that would be absolutely fine, because the probabilities are just dipping down to being really small by then. You might want to just put, you know, relatively big negative number in there, so we could go minus 1,000 or something. The upper limit is 33. Standard deviation is 4, and the mean is 30. So you just put those values in, press equals each time, equals at the end, and I get 0.7734. The link I've shown you as well to someone else doing this, he actually puts as his low band like minus 9 times 10 to the 99 or something. That's really overkill. If you want to do that, go for it, but you don't need to. Right, because this is continuous, the probability of x being bigger than 24 is exactly the same as the probability of x being greater than or equal to 24. Because in this one here, you can get as close as you want to 24. So the two things are the same. It's a bit like the reasoning behind 0.999 recurring being equal to 1. It's that same idea. So we're dealing with a continuous variable here. So to find this one, if you press all clear, it takes you back to there. My lower limit now is 24. And it's not a bad idea to sketch these. You'll probably find later on you'll need to sketch them in the questions. So I'm looking for this probability here. So if I could encourage you to sketch them, please, that'd be great. Lower limit is 24. I'm sorry, this has come out quite dark. 24 equals upper limit. I need to go 30 plus 20, at least 50, but you might as well just chuck in a big number. So I've just put in 1,000. Standard deviation and the mean are saved from the last question, and I get 0.9332 for that. I can hardly read this myself, so you might want to just work along with me on this. The probability of being between 2, so between 33.5 and 35.2. So 33.5, 35.2. That's nice and easy. So you just put in your lower limit as 33.5, upper limit as 35.2, and then standard deviation and mean is still saved from the last question, so I don't need to re-enter those. And that comes as 0.0940. This probability here that you're less than 27 or bigger than 32, if I sketch this, I think you'll see it. So that's 30, less than 27, bigger than 32. If you want all the other, that's there. Total area under the curve is 1, so you can actually do 1 minus the probability of being between the two if you want to. Or you could find this one and then find that one and then add your two results together. Up to you. So that one there, I can put in 27 for my lower bound, 32 for my upper bound, and then that kicks me back a decimal of 0.464835. And you see 1 minus that, sorry, that's meant to be a 5. So what you can do with that value is you can store it. So you can press store X, and that will store it to X. Then I can do menu 1, it takes me back to my calculator menu, and then do 1 minus X, and I get 0.5352 to 4 decimal places. So these are often to 4 decimal places because the old tables were. So you'll see a lot of 4 decimal places, sorry you can't see that, rather than 3 sig fig on these. And the other thing I wanted to mention while I'm here is because the probability of x being greater than or equal to 24 is the same as the probability x being bigger than 24, which I was talking about earlier. If you think about what this means, it means that the probability of x equaling 24 exactly actually is equal to 0. And because it's a continuous variable, so we're not dealing with a discrete distribution, that's a continuous distribution, there's infinitely many values that x can take. So the probability of x equaling a particular value precisely, not rounded to 24, precisely is equal to 0. So that's something for you to think about. There is a PD button on your calculator. What that tells you actually is the probability that 23.5 is less than or equal to x is less than 24.5. So it's saying if you rounded x to an integer, what's the probability is 24. So that's quite different to the probability x equals 24. So the probability of x being a particular value in the normal distribution is always 0 because it's continuous. And those should have been capital X's. I'm being a perfectionist. You know I'm a perfectionist by now, surely, but yeah, they should be capital X's. So I just want you to have a go at those, but I have put another link to someone else doing this as well on your lesson plan, and he's done it all a bit more snazzily on YouTube. So you might be able to see what he's doing on his calculator a bit better than mine. So do feel free to watch that one too.